Hi and Assalamualaikum to my panels and all viewers. In this video, I will be presenting my final year Project 1 MEC601 with the title Development of a Small-Scale Vacuum Forming Machine. Firstly, let me introduce myself. My name is Fazlaili binti Nuza Azam from School of Mechanical Engineering UiTM Shah Alam. My supervisor for this project is Prof. Madya Dr. Abdul Halim Abdullah. Before we start with the video, here are the contents of my presentations. Let's start with the project summary. Generally, this project are focusing on developing a smaller scale vacuum forming machine compared to the industrial vacuum former. This vacuum former will be designed so that it can be powered by a common commercial vacuum cleaner, making it can be easily used by any user. For vacuum forming process, there are a range of materials that can be used. Hence, the project also aims to find out the effects of different material and process parameter setting to the quality of the product produced from vacuum forming processes. Introduction. So what is vacuum forming process? Vacuum forming process is also considered as thermoforming process, and thermoforming is one of the most basic and oldest ways of manufacturing plastics. It is used to make anything from a simple packaging trays to a high-impact airplane cockpit covers. How does the vacuum forming process works? Vacuum forming process starts with heating the plastic sheet and draped over a mold while a vacuum is applied. The vacuum will suck out all the air trapped between the sheet and the mold so that the sheet can be formed around the mold. After the formed plastic are allowed to cool to a certain temperature, the plastic can be released from the mold and to be trimmed. Vacuum forming is also considered as rapid manufacturing processes where the process are done in a continuous high-speed process that can generate thousands of finished parts every hour. However, it is also depends on the machine and the mold size, as well as the size of the parts being made. Next is problem statement. Most vacuum former available right now are industrial size, where it is very big and expensive as well as uses high power. The presence of a small or commercial size vacuum forming machine can be accessible to more users, especially small businesses or hobbies, for making custom parts or products. Next is using different material and different setting parameters can affect the quality of the result product, which sometimes can lead to defects. Here are the objectives of this project, which is to develop a small-scale vacuum forming machine, to design a vacuum former which can be powered by a commercial vacuum cleaner, and to investigate the effect of different setting parameters in fabricating the vacuum forming machine. There are some scope of limitation for this project, which are the design are developed to be cost efficient. Hence, the material that will be within the selection are the most suitable and low-cost material. Next, the study on the material for vacuum forming processes will be on the material that are already existed in the market. Now, I will explain some of my findings in my literature review. So, vacuum forming is the process of shaping plastic material. It's a method of plastic thermoforming require only one mold and vacuum pressure to achieve the desired parts geometry. Therefore, it is perfect for pieces that just need to be perfectly formed on one side. Based on my findings, there are 4 important components of a vacuum forming machine that makes it work how it is. The components are the clamping mechanism, heating element, vacuum process, and the cooling and release. For the clamping mechanism, it has to be strong enough to hold the material. The heating element, it is important that the heat element are able to heat the material uniformly across the whole surface area and thickness in order to achieve the best vacuum forming results. Next is one of the most important elements, which is the vacuum process. So after the material has been heated to the desired temperature, a vacuum can be used to aid in the formation of the sheet. Lastly, cooling and release. The formed plastic must be allowed to cool to a certain temperature before being released from the mold. This is to prevent deformation, which can happen if it releases too soon. The next topic is on vacuum forming materials. So the most common thermoplastic material used for vacuum forming are acrylics, ABS, polycarbonate, and PETG. Each of these materials has its own set of characteristics that are derived from its atomic structure, qualities, and range of additives that can affect the result of the process. The optimal properties for material to be utilized in vacuum forming process are easy to form with a low forming temperature, thermal strength and good flow, strong impact strength, and low shrinkage after cooling. According to another study, the film thickness at the portion sidewall reduces as the film heating time and plug depth increase, but the thickness at the bottom was found to exhibit the opposite behavior. Next, I will get into the methodology of this project. Here are the project flowchart of this project. Generally, the project will start with study on related journals, vacuum forming machine design process, fabrication, and product testing. However, for FYP1, it will only cover until the designing process and the rest will be continued for FYP2. The designing process starts with conceptual design, which is to determine the concept of the design. Next is detailed design. In detailed design, the finalized design of the product are achieved, as well as the material that are going to be used for the fabrication. For this design process, the software. As for the fabrication, it will be based on the design developed. The fabrication will also be using the appropriate tools and suitable materials that are the most cost efficient. And for product testing, it is where the products are tested for its functionality and also to analyze the effect of different setting parameters for the vacuum forming process towards the quality of the results. Lastly, expected result. As the preliminary results, here are the conceptual design used to determine the overall vacuum forming machine design. The base was chosen to be an inclined plane inside the base to remove unnecessary space that can cause pressure losses. Next, the plane for the vacuum base cover will have arrays of holes drilled onto the plywood to distribute the negative pressure evenly. Then, the heating coils are chosen for the heating element compared to the hot air due to heating coil can produce higher temperature in a shorter time. The movable carriage are then set to be a linear so that the material can be delivered as quickly and as efficient as possible. Shown in the video are the final design of the vacuum forming machine. It has all the important components which are the oven, movable carriage, vacuum box, and the structure. As mentioned before, the oven or heating element should be able to produce the desired power and temperature and distributed it evenly. The movable carriage are designed to be attached to the steel rod structure with 4 linear bearings so that it can straightly lower the material onto the vacuum box after being heated without any disturbance. Next, the vacuum box has both the concept chosen, which is the arrays of small holes and inclined plane to generate the negative pressure efficiently. Lastly, the structure is aimed to be low in material cost, easy to fabricate, and also rigid. Therefore, the main material used are plywood and 10mm steel rods. The plywood also help with preventing unwanted heat losses. The steel rods are also connected using linear shaft support brackets that are specifically made for 10mm steel rod. And that is all for the expected results. That is all from me. I hope I give clear explanation on my ongoing project. Thank you for listening to my presentation until the end. Thank you.